Cool. So we are about halfway, a little less than halfway through this. It doesn't look like it because it'll continue to grow as we go. But yeah, we're moving on through Pandas here, and so we are going to pull back our Boston 17 data now. So built-in methods are methods that are frequently used when using Pandas to make your life easier. It's possible to spend a whole week simply exploring the built-in functions supported by data frames in Pandas. Here, however, we will simply highlight a few ones that will be useful. To give you an idea of what's possible out of the box with Pandas. You don't even have to write your own functions here. You can just use ones that already exist. And there are more of them. But again, our goal is to get you from 0 to operating as fast as possible and try to not get too lost in the weeds. So we can say boss 17, booze 17, boss 17 dot head. And this should automatically pull back, 5 rows. And that's very nice. We could also say if we wanted more of them or less of them, we could say I just want 3. I think you could do more of them. Yeah, you can. But it defaults to 5. So keep that in mind as well, that anytime you use head, it will default to 5. Tail does the exact same thing. Boss 17 dot tail. And there you go. You get the last values in whatever your data set is. Very nice. We have shape, which is pretty cool, which will tell us, again, the dimensions of it, right? A data frame has a shape property, just like a NumPy matrix. No parameters. There's no it's just an attribute of the data already. Cool. Describe. This one's super cool. And so describe, I think I actually have it up here somewhere. Where's my describe? There we go. Cool. Pandas describe is used to view some basic statistical details like percentile, mean, standard deviation, etc. So this is where we're going to start moving into more of the statistics part of things. And there are some parameters. We'll look at those in just a moment. But like I said, I do recommend checking out for some of these, looking through Geeks for Geeks and seeing what other cool tools exist, especially when you're taking time to do your analysis for your final projects as well. Taking the time to discover new tools and actually get some familiarity and comfort with them. So I'll say this too. I have a buddy who works at an unnamed company, and his boss the other day apparently, who is a self-described Python fanatic, and has been a self-described Python fanatic for 8 years at a unnamed large tech company. Just last week was like, oh, I didn't know that you could use .get and give it parameters, right? So let's look at the W3 schools. .get. Try again. There we go. Wiki. And so you can actually pass in a key name and a value. And that's an optional value to return if the specified key does not exist. But these are things that you just go and read these things and learn about them. And you don't have to have it memorized. But just to say, oh, wait a second, we're using .get here, but what if there's some other thing we could be using, right? And so reading through things for describe and stuff like that might give you a little bit more in-depth for some of your tools, and it is a very valuable thing. I'm not telling you to read all of them. That would be a lot of time, which is also part of why we're moving through this at the pace that we are. But anyways, .describe. So we're going to say boss 18 .describe. And so first we're just going to do it regular vanilla describe. But this is very cool, right? We get accounts, how many values are in each of these, and there's 20 for all of them. What's the mean of all these values? And that's great. The standard deviation for them, and how wide those variations are. What's the minimum value? What's the this is our interquartile range, right? So that's when we had our box plots, things like that. 25%, so 50%, this is the median, and 25% is going to be the median between the lowest and median, et cetera, et cetera. So we have these quartile ranges that it calculates for us, which is great. And then we've got our max. We could also say, what if we want more? What if I want more information? So we could say include equals, you have to spell it right first, include equals all. And we get more stuff. We do get some interesting things. So like, for example, position, there's 20 values here, and there's 11 unique values. But we end up with some other interesting stuff here, like NaN, and that's not a number. And that's because you can't take the average of shortstop, catcher, and pitcher, right? What's the average between those three? You can't do that. They're strings, right? And so it's not going to try and calculate that for us. And so same thing goes for a lot of these other not a number values. But that describe thing is really great at getting you a really quick statistical overview of what's going on. And that's something that, like, as you're looking at it, you might want to take some time and say, are any of these things odd? Is this what I expected? So on and so forth. So that's pretty great. Sort values. And so we can actually sort based on different labels, things like that. And so we can say sorted data equals data.sort values. We say ages. And we're going to say kind equals merge sort. And so you can actually choose which kind of sorting algorithm you want to use, which again is very nice to not have to do that yourself. Reset index drop equals true. So in this case, we've sorted our data based on the ages is essentially what we want to see here. And so sure enough, we get those back, and then we put it back to the way it was before. So there you go. Sort of on the ages. And keep in mind that these values, again, we use them as primary keys. We've kind of created a new data frame called sorted data. And so rather than taking data and sorting that at its core, we've actually just taken sorted data and making a new one, which is why these values are still in order, even though we've shuffled the order of everything else around. Cool. All right, so dot columns. Also, by the way, so because we used random to generate these numbers, if yours look a little different than mine, that's okay. It was generated by your computer, not a central location. All right, columns. This is pretty straightforward. I think we talked about keys earlier already. I'm pretty confident we did. But even if we didn't, so here's key. Yeah, we did. We sure did. Great. All right. So yeah, so we've got our columns here, and so these are all the different column headers at the very top. Again, this is very useful for saying what things am I going to be looking at, what data I'm going to have, and just pulling those back. And then we took the type, and that was an index, and then we took back the keys. And we talked about what that was earlier as well, and so again, that's going to be an index data type there for that. Cool beans. All right, in-class exercise number 2, describe and sort the Boston Red Sox hitting data. Take the data that you read in earlier from the Red Sox CSVs and use the describe method to understand the data better. Compare the 2 years and decide which team is having the better year. Then sort the values based on batting average. Pretty spicy question, pretty fun. Should be great. And keep in mind that all the things that are in here, all of these are rows that you can pull back. Just think about that as well. So that's going to be my big hint for you. And if you need help with this question later, reach out and we can help you out and explain things to you. That'll be fine. We're going to move on to filtration. It's cool. So let's look at how to filter data frames for rows that fulfill specific. This is very similar to how NumPy does it. So the subsetting is as well, right? So we can say data ages is greater or equal to 25. And sure enough, we get these Boolean values back. Delightful. Very easy. And you can see the data type for bool here tells us what these are going to be. So we've seen some of these like int 64, int 32. That's how many digits long our integers can be inside of those values. Again, this comes down to how we tell our computers where we're going to store that data so that they make enough space for the data to arrive when it comes. Cool. Subsetting. So if you wanted to see what the values were, this would be just like NumPy. So we can say data, ages, and then where that's greater than or equal to 25. And sure enough, and then we get all those values back. And that's pretty nifty. Great. Column transformations. Rarely, if ever, will the columns in the original raw data frame read from CSV or database table be the ones you actually need for your analysis, right? If the data is already there, you wouldn't really have to pull it. You can just look at it. So you will spend lots of time constantly transforming columns or groups of columns using general computational operations. We're going to talk about some more of the like general areas of what we do with data analysis and exploratory data, especially once we get to R. So when we get to R, keep in mind these tools are fitting into kind of different categories, different parts of things. But I digress. Using general computational operations to produce new ones that are the functions of the old ones. Right, so we can take old data and create new columns and information for it. Pandas has full support for this. Consider the following data frame containing membership term and renewal number for a group of customers, right? So we've created a random set of customer IDs, of renewal numbers, a customer dictionary, and then we made terms in years. And when we put all this stuff together, we can see how long they've been a customer. But there's still some information that we maybe don't know yet that we're not having access to just yet. And again, we made a data frame from this information. This is just a dictionary that we used to create our data frame. So we want to see some interesting things. So right here, this renewal number is how many times something has been renewed. And then the term is how many terms it's been renewed, right? For example, 4 times 0.5, this is going to be 2 years of customer 1040 being our customer, whereas 1083 is going to be 3 times 1, so it'll be 3 full years of them being our customer. But we can't, it's kind of hard to look at here, and we might want to do some other operations on whatever value these two things multiplied together is. So let's go ahead and multiply them together. Let's create a new column, and this is very easy to do. It's very similar to creating a new column in a dictionary, or a new item in a dictionary. We just say customer tenure, and we're going to say this is equal to customers renewal number times customers term in years. And then let's have a look at customers now. Customer, just one customer. Nope, customers. Come on. There we go. And sure enough, we get customer tenure, and we get these values here, right? So, very nice. If what you want to do to a column that can't be represented by simple mathematical operations, if what you want to do to a column can't be represented by simple mathematical operations, like multiplying things together, you can write your own user-defined function, or UDF, with the full customizability available in Python and any external Python packages, like NumPy, Pandas, whatever else we might be using. And then you can map it directly onto a column, right? And again, a map is, it runs a loop over the pieces of data in an iterable of some sort and applies a function to them. So let's add some ages to our customer data frame and then classify them into our custom-defined grouping scheme. All right, so, and then Pandas has apply as its specific function for mapping. It's a little bit different, but it operates basically the same. I think it's easier to use. But don't tell Guido that I said that. All right, so we're going to create a new column for our ages, and we're going to say customers ages equals np.random.randint, and we're going to have 18 to 70, and we're going to make a list that's 10 items long, because again, this is 10 items long, so we want to make sure that those are lined up. So their ages are going to be between the ages of 18 and 70. Great. And then we're going to make a user-defined function. So let's just go real quick, just to have a look at customers. Let's see what that looks like. Lo and behold, we have ages here. So each of our customers now has an age. Marvelous. All right, so now we're going to make our function. And this is pretty straightforward Python. This part should be pretty easy. And we've actually done problems like this before. I'm going to say def make age groups. We're going to pass in age, right? So it's going to end up going through these ages and doing something with it. I'm going to say if 10 is less than or equal to age and 20 is greater than age, then we're going to return teenager. Cool. If 20 is less than or equal to age and 35 is greater than age, we're going to return young adult. If 35 is less than or equal to age, and 65 is greater than age. Return adult. If 65 is less than or equal to age, then we're going to return senior. Okay, cool. So that's all fine, right? And that's a kind of function that we've written before, using if-else statements. And we know that our parameters are going to be between 10 and ultimately 70 because we put these values in there. I guess we have 18 in there as well, so we might have a couple teenagers. Maybe we'll see. But that's fine. And I'm going to comment this out because we already ran that, so I don't want to generate more ages columns or overwrite things. We probably shouldn't have any teenagers here either, so I think they're all going to be over a certain age. But it might be hard to see that. It might be difficult to look at. So we're going to generate our own new one there, and we're going to pass in age group. Okay, so that's going to be a new one. And it's going to be equal to customers ages dot apply. And this is where we're going to pass in that function, make age groups. Because again, you remember when we just print a function without the parentheses or running it, that will just tell Python where that is, right? So if we go back to this and I were to just do print make age groups, right? We end up with the function and we get that location back in memory. So we're just telling it, hey, go look at that location in memory, but we don't have to run it. The apply is what's actually going to run it on all of those. And that's desirable. That's what we want there. So I should be able to do that. And then I'm going to put out customers again at the end. And sure enough, we get this age group column that's going to go over those values, and it has categorized them for us. Really, really cool stuff. Really cool stuff. Very powerful, very potent. So we've got ages here. And again, 27 is going to be a young adult. 28 is young adult. 67 is a senior. And that's really cool. But what if we want to generate more than one column or interact with more than one column? This can be really cool too. So I'm going to make another function. And we're going to talk about apply in just a second. But we're going to say def make loyalty age group. We're going to look at row. And we're going to have age equals row ages, right? So whatever data we're passing in here, whatever data set we're passing in, or really applying this loop to, we're going to make an ages, and then we're going to say tenure is going to be equal to row of customer tenure. If 10 is less than or equal to age, again, this is what we just had. So we can actually just copy paste this back from here again. Should get that space in there. So we can copy that, paste that back in. So that'll be all good. And then we're gonna have another if else statement, right? If tenure is greater than 2.0, right? We're gonna say loyalty age group equals F loyal, we'll capitalize that, loyal age group. Cool. And otherwise, we're going to say loyalty age group equals F string. We're going to say new age group. And what we're going to do at the end here, we're going to return loyalty age group. Cool. What does it do? Let's go ahead and add it to an actual function here. So loyalty age group equals, and again, we're just making a new column here, just like adding a new item to a dictionary, but we're just adding a new column to our data frame here. Customers dot apply make loyalty age group and axis equals 1. And so this is going to be 1 is going to be applying to the the x-axis, sorry. And so that way we're not making a new row. Whoops, what do we do here? Customers. It's like the third time I've done that. And then let's see it at the end here. Great. So there we go. What happened here? What happened here? If tenure, return, loyalty, age group. That looks totally fine to me. Maybe I just spelled that wrong. Why have we done this? Why have we done this? All right, debugging time. Let me pause. All right, figured it out. Just kidding, I lied. Rather than return, we need to set age group equal to that. That's why that did not go through. Age group. Age group. Oh, equals. There we go. So then we are managing to use the multiple things, and we're able to put those in there. And that's great. That's what we wanted. Pretty cool. All right. So in-class exercise 3 will be to create your own UDF. So using the Boston Red Sox data, create your own UDF, which creates a new column called All-Star, and puts every player with either a batting average over 280 or an on-base percentage of over 360 with a result of yes in the column and no if not. It's a little bit tricky. If it doesn't look exactly like this, that's okay. And so like you're not going to necessarily have this nice dotted line. That's just how we formatted that. It will probably look closer to something like, I'm just going to copy this in here. It'll probably look closer to something like this. So if it doesn't have the nice little line through there, that's fine. But that is what we are ultimately kind of looking for. So that is your in-class exercise. We're going to break there, and we will work through the last of this document in the next video. I'll see you there.